between 34 and about 33 years since we last stood in one of these.
Yeah, absolutely.
But, I think there's some familiar components here, and some familiar nightmares and experiences that we all had in terms of trying to get these things serviceable and ready for the integrity checks and the engines going back in.
Yeah.
You know, so I think we've got a Reheat fuel pump right in front of you there.
Yeah, that's it. Yeah.
And now we've got a bit of an argument going, because that used to pump fuel, I believe, at 400 psi. We used to pressure check it at 1.5 times. That's 600. Mario thinks it's 600. Murph, what do you reckon?
Oh,
can you
go for 500.
Yeah, I could go for that, couldn't I? I'm going to say 600 as well.
600 would be. So your fuel filter would be here, Mario. Is that right?
Yeah. Well, if we start down there, the LP supply from the wing used to come in on this big fat pipe here, from there all the way through here, and then this is the main engine connection.
Yeah, for main fuel.
For the main fuel. With a very expensive braided pipe that Dave Yates used to use for his stag, I believe.
Yeah.
If you read this, Dave, sorry, your secret's out.
Yeah.
And then there's the Reheat fuel filter and up into the pump, and the pump would then pressurise it to 600 psi and away for Reheat.
Yeah.
But Murph, I mean, you'll remember, oh my word, the FRS couplings and the joy we had
with fondness. Yeah. Air driven, wasn't it? The Reheat fuel pump. So it took air from the engine. Yeah. Which actually it took that much air. I think it used to sort of drop the RPM of 1 or 2%.
Yeah.
Yeah. So the fuel came. That's the
heat exchanger.
Fuel cooled oil cooler. So that used to cool hydraulic oil, didn't it?
Yeah.
They could leak.
A lot
as well. Yeah, you get fuel in the hydraulic system,
and they were extremely delicate as well, as I remember, because the aluminium body, with steel threads, not good combination if you were clumsy.
So that would pre-warm the fuel prior to it getting into combustion. So that would give it a more combustible.
If you think about it, it's just come out of the wing.
Yeah, it's cold.
So it's cold.
Yeah.
And even though you've got fuel system icing inhibitor in the fuel, warming it up a bit didn't do it any harm. So.
Yeah. Okay. So coming in through those dreaded FRS couplings, which we'll talk about in a moment. Yeah. Right. And that then had two feeds, one for the main fuel for the number engine. Number one engine bay, which we're in at the moment. And then secondary would feed the Reheat fuel pump through the filter into there. Yeah. Okay. And therefore that was activated by
this Reheat switch.
Okay.
I believe, if I'm right. Yeah. And driven by air off the engine from the pump.
And therefore it would pump down into the spider at the back of the jet pipe. Yeah. And then that would be ignited by a drop of fuel coming in at the back of the Avon. Yeah. Called a hot shot. Right. Okay. And that would streak down, so there'd be a delay between selection of Reheat and actually the Reheat getting ignited. Is that correct?
I think it had about 2 seconds to light up.
2 seconds.
By which time, if it didn't light up after 2 seconds, there'd be so much unignited fuel in the jet pipe that so it automatically shut off. Yeah. And as you were saying earlier, that time delay could be anything between straight away and 2 seconds. And so the first time you went into Reheat,
you were waiting for it.
You knew that if it were, hang on, I mean, this is really kaboom, and it really did go with a bang.
Absolutely. And you're hanging on for dear life on that tailplane, weren't you? Looking through that tiny panel.
Well, that's an interesting point you bring us on to, Mario. So talk us through. You'd be on comms to whoever was running the engines in the cockpit.
It's called the Mike Tell. Yeah, if I'm right.
That's right. Yeah.
It's a Mike Tell. So you'd say, right, okay, go into Reheat, and he'd say, okay, I'm going in now. And then you'd wait. And the longer the wait, the bigger the bang. Yes. And it was like, and you're hanging on for dear life on this tailplane, looking through a tiny panel with the air turbine gearbox exhaust blasting away near your head, and then it would go in. It was life affirming.
You'd be checking for
a leak on the
to see if that leaked.
Absolutely.
Health and safety executive would have a complete and utter heart attack.
I don't think this plane was designed with.
No, it wasn't. No, those two things wouldn't have been brought into mind. Okay, so that's I guess Reheat.
Well, I tell you what, go back to the FRS couplings. We had a chat with Ian Black this morning, And Ian said, basically, and I was really surprised, if he'd have known how this was designed now, he would have considered himself crazy to go flying in one of these. And as all three of us are engine men, we actually felt a huge sense of responsibility. I certainly did myself, to make sure that what we did was safe. And that was the overriding thing for me. These FRS couplings were the cause of many lightning fires and losses. And they introduced a fire integrity program with, what was his name, Rowley Elliott. Rowley Elliott is to come along and check your work. We'd have to x-ray them on a night shift. Great fun. Unpaid overtime.
But so Murph, you know, we've got there were 3 different types of FRS couplings, right? So let's test your memory here.
Okay then, 110s, like that. So that had a one-piece seal in it. Then there was the 380, which had a 2-piece seal. And then the other one was a 1230. It was almost the same as a 380, but there were retaining rings to I think under certain conditions with the wings flexing, they used to put those in high stress areas, the 1230s, because it was possible to pull the pipes out of the coupling. So the retaining rings in the 1230
held it in situ.
Held it in, yeah. And they all had different tolerances to set them up. On these 110s, you couldn't have any out of alignment. It had to be absolutely no tolerance, truly parallel.
There was no offset. Lateral offset, horizontal offset, no angles, nothing. And basically, the main fuel pipe runs in an engine bay that's over 300 degrees centigrade, so prone to fire. And you've got these pipes that are just basically open-ended pipes connected by a piece of rubber and clamped together with these. And if they were offset, they would leak and hence cause a fire. So we took great pains to get these right. When an engine was dropped, when we removed an engine on a squadron or whatever, if these had been undisturbed for, you had 28 days, didn't you? If the engine had been in longer than 28 days, I believe they had to x-ray them again.
I can't
that was a squadron.
That does ring a bell. So you're always nervous, weren't you? Once you'd spent hours getting them aligned and fashioning different pieces to get them to fit. And I think, as you were saying earlier on, Mary, you could go to stores and order 4 different pipes, and there'd be 4 different shapes of those pipes, and then you'd get the one that would fit the best. Have to fashion it to get that true alignment. Then you connect it all up, and actually, when you can connect them, they can come together, can't they? So they can change.
Hence the witness tape there.
Yes.
Yeah, so that's right.
Green, and then you could measure that. You could measure that before assembly.
And absolutely afterwards.
It's a really good observation.
Actually. I'd actually forgotten about the witness tape.
Well,
crikey.
I knew you were going to be good on this, Murph. And then we would pressure check them. At 1.5 times operating pressure. And then the NDT guys would come round at night and X-ray them. And we'd all be waiting for the results coming in.
Well, so there were some lucky volunteers that stayed there at night with them.
Like expectant fathers in the outside the delivery room.
What's that? That's a good point. That is a really good point. So
no,
FRS couplings,
rubbish. You're going to have to take all those apart again. And must try harder.
But that was only just one of the handcrafted systems on the thing. The main air system was. Most of it's in a number 2 engine bay, but that was another piece of handcrafted, no tolerance, no leaks allowed system that you couldn't afford to get wrong, because it would result in a hot air leak near to pipes, near to the engine, and catastrophe awaited.
So that air then was tapped off the engines through, I think, one of these, and also you had to get the main air. Do you remember that big brass? Once the engine had gone on, you had to then. That was a fiddle, because you'd have to. The trick was before the engine.
Bearers went in.
Okay.
One
you got these here, and then you got the main engine
these
braces
2
there. So you'd have to try and get the team to wobble it on the winches while you did the nut.
That's
and then getting that nut tight
with the big bar.
With the big bar that you banged on
Excalibur.
it. Yeah, that's what
it was called.
That's right. Yeah, that's right. So that was a massive fiddle, wasn't it?
Oh my God!
And therefore, runners pass. So you'd have this pipe system tapping off hot air from the various different stage on the compressor. Can't remember which stage it tapped it.
Well, 15th stage.
Stage 15.
There was a stage 0, so it had 16 stages. But, it was stage 15. Yeah.
Right. Okay. And then what that would do then? That would run it down to the air turbine gearbox. Now talk us through what that did.
What, the air turbine gearbox, which is way down, really sitting aside the two reheat pipes. So it carried an alternator and it carried a generator. And it also carried there was a induction cooling fan on it, wasn't there, to draw air in. So basically, that was its function. The air-driven big turbine generating power, both AC and DC, for the aircraft systems.
And getting one of those air turbine gearboxes replaced
was fun.
Another engine person's nightmare.
Yes.
The riggers used to think they had it easy, but I'm telling you, it was us.
Right, that had it hard.
It was us that had it tough.
Maybe there's a few people that might be watching this.
I hope so.
Right, in violent disagreement with you.
I hope so.
But, so we've got.
There was a special cradle for that air turbine gearbox, because it probably, I don't know, it weighed a few hundred pounds, or even kilos. And that cradle used to run on the jet pipe rails, which you can still actually see one of them here. But I always found, I don't know about you, you'd winch it down onto the cradle, try and roll it along the rails, and it'd fall off. So it was much easier just to forget about the cradle, put it in a big plastic drip tray and a couple of big bit of foam, and carry it out.
And it was a lump, wasn't it?
There was a few tricks to the trade, weren't there?
Well, that seems brutal in hindsight, but it was there was no chance of it doing any damage by falling off the rails and landing on a pipe.
You remind me of something actually, where, and I won't say the person's name, but where if you overfilled the number 2 engine, and the number 1, if you overfilled it with oil, you could drop the ventral and just you could
siphon all the oil out.
With the number 2, I believe it had to come out, and there was a certain character that we used to work with, who invented this idea. So you had your OX38 oil, do you remember that?
Yes.
The Castrol, wasn't it?
Yeah.
And it had a coupling on it, and the coupling used to release a valve, a non-return valve, when you connected the oil to it, and you'd pump it up and watch but there was a delay between the pump and actually then the oil coming in. So if you got that wrong, you could overfill. So what he did is he cut one of those couplings off at the bottom pipe, connected that up, started the number 2 engine, it blew out a load of oil, and somebody was there to got the levels down, job done. Everything was cleaned up, nobody would have known any different, and that saved the number 2 engine change. Probably not legitimate, and if anybody, nobody would have perhaps been happy to sign that off. But
improvise, adapt, overcome.
Exactly. And we had to have a few of those, didn't we? Bent spanners, welded spanners, and all sorts that were just not standard.